Hi, curious minds. Right now, while you're watching this video, billions of creatures are living inside you. Animals, single-celled organisms, microscopic life. You are a walking zoo, and most of the residents you've never once felt. Some are harmless neighbors. Some are the reason you're still alive, and one of them might be influencing your behavior right now. Let's go. Demodex. You have pores on your face, and in most of them, especially around your eyelashes, there are mites. They're called Demodex, tiny, between 0.1 and 0.4 millimeters long, thinner than a human hair, invisible to the naked eye. They live on nearly every adult on the planet. Studies put the number at over 90%, and by the time you're 70, it's essentially 100%. So if you're worried about having them, don't. You've already lost. When I found that out, I spent the next 15 minutes staring at myself in the mirror. To no avail, of course. During the day, they sit quietly inside your follicles. At night, they crawl out to mate, back by dawn. Think of them as the night shift workers of your face. Clock in at midnight, clock out before sunrise, and never bother anyone about it. Here's the thing though, Demodex is not a parasite in the traditional sense. It feeds on dead skin cells and sebum, stuff your body was throwing away anyway. It actually helps keep your pores clear, your personal zero-cost skincare routine, except it comes with 8 legs and no consent form. Trouble only starts when the immune system weakens and the population explodes, in some cases, hundreds of times above normal. For years, the belief was that Demodex has no anus, that it stores every meal it ever eats for its whole life, then dumps the entire load onto your skin when it dies, triggering breakouts. But in 2022, a team led by Dr. Alejandra Perotti took a deep look at the mite's DNA and settled it. It does have an anus. The poor thing had been blamed for your bad skin for nothing. Demodex lives quietly, causes no trouble, and pays rent by cleaning your pores. The ideal tenant, if only it didn't live and mate on your face. And that was just the surface, literally. Inside, it gets stranger. Gut microbiome. Right now, your gut contains somewhere between 38 and 40 trillion bacterial cells, roughly the same number as all your own body cells. 1 to 1! You're not a human with bacteria inside, you're a co-working space. And you and the bacteria are working toward the same goal, keeping this body alive. The whole community weighs about 1.5 kilograms, roughly a small cat. A living one, with opinions of its own. But the numbers aren't the interesting part. The job is. These bacteria synthesize vitamins B and K that your body cannot produce on its own. They break down complex carbohydrates that would otherwise pass through useless. They train your immune system to tell real threats from background noise. They're running a chemistry lab you never applied to work at, and you'd be in serious trouble if they quit. And here's the one that surprises people. About 90% of the serotonin in your body, the so-called happiness hormone, is produced down in your gut, not your brain. It doesn't directly run your mood from there. Its job is mostly digestion, but the gut and the brain are wired together, talking constantly. So a surprising slice of how you feel starts in a place you'd never think to look. When antibiotics wipe out this ecosystem, the fallout is real. Digestive problems, lowered immunity, sometimes depression. You didn't cure yourself. You laid off half the department without severance. Appreciate the people doing the work for you, even if you've never met them, especially then. We've covered the gut. Let's go one floor up. Helicobacter pylori. We all know there's acid in your stomach, and acid, to a living thing, means pain. Your stomach acid sits between pH 1.5 and 3.5. Acid strong enough to corrode metal and to kill most microorganisms that touch it. It's basically a sterilization chamber. And yet, about 44% of people on Earth have a bacterium thriving inside that chamber. It's called Helicobacter pylori. How does it pull that off? H. pylori produces an enzyme that breaks down urea from the gastric juice into ammonia. That ammonia neutralizes the acid right around the bacterium, wrapping it in a tiny personal bathyscaphe of safe pH in the middle of a corrosive sea. What does it eat? The urea it's already breaking down, plus nutrients scraped from the stomach lining for dessert. Most carriers never feel a thing. Some researchers now believe its long presence in humans may be evolutionarily normal, serving functions we haven't fully mapped. One consistent finding, children carrying H. pylori develop allergies at noticeably lower rates. An immune system with something to do works more precisely. But in some people, it does cause gastritis and ulcers, and we only know that because of one man's spectacularly reckless decision. In 1984, an Australian doctor named Barry Marshall was so sick of nobody believing his theory that he drank a flask of H. pylori himself. He gave himself gastritis on purpose and proved he was right. 20 years later, it won him the Nobel Prize. I'm sure there's a faster, less horrifying way to win an argument. It conquered the one place nothing else could live, and mostly behaves. Mostly. So far, every creature here moved in politely. The next ones didn't bother with the paperwork. By the way, if you're enjoying this, I post content like this every week. Subscribe button is right there. Appreciate it. Let's get back to it. Pinworms. Pinworms are nematodes, a type of parasitic worm about a centimeter long. Infection is simple enough. Eggs enter through the hands, settles in the intestine, hatch. Then comes the creative part of its life cycle. At night, the females crawl out to the exit point and lay around 10,000 eggs in one go. That causes itching. The host scratches in their sleep, eggs get under the fingernails, and by morning, they're back in the mouth. Cycle complete. The itching isn't a side effect, it's the whole point. It makes you do the spreading. Somehow, a worm the size of a fingernail outsourced its entire reproduction to you, and you handle the logistics in your sleep for free. The job description: scratch and deliver. Over 1 billion people carry pinworms at any given time, the most widespread worm infection on the planet. Most of them have no idea they're on the payroll. Tapeworms. Tapeworms play a completely different game of scale. Some species reach 10 meters in length. The longest one ever pulled from a human host was over 18 meters. 18 meters! Your entire gut, small and large intestine together, is only about 6 meters long in a living body. This worm was roughly 3 times longer than the home it folded itself into. For years! These worms can live in the intestine for a long time, completely unnoticed. They anchor to the intestinal wall, absorb nutrients straight through their skin, and just grow, inch by inch. Unlike the microbiome, tapeworms and pinworms give nothing back. Pure freeloaders. And yet, our immune systems have lived alongside intestinal worms for so long that when some regions started aggressively deworming their populations, autoimmune disease rates climbed. An immune system with no familiar enemies starts attacking its own host. Nature likes balance. Sometimes even the uninvited turn out to be holding the system together. Now, the one that's probably been on your mind since the intro. It lives in your brain, and based on the data, it may already be nudging the decisions you think are yours. Toxoplasma. Toxoplasma gondii is a single-celled parasite. You pick it up mainly through undercooked meat and unwashed produce, and a couple of other routes we'll politely leave alone. After infection, it moves into your tissues and forms cysts, tiny hardened capsules in your muscles, your liver, and your brain. Estimated global carriers? Between 30 and 50% of the population. 1 in every 2 people on Earth. In most cases, no symptoms. The immune system keeps it contained. The cysts sit quietly, a permanent house guest who never makes a sound. Here's what sets it apart from everything else on this list. A healthy mouse is hardwired to fear the smell of cat urine, one of the deepest instincts in rodent biology. A mouse infected with Toxoplasma loses that fear. Researchers documented infected mice actively seeking the scent out. The prey starts walking toward the predator on its own. The mechanism. Toxoplasma targets the part of the brain that handles fear and rewires it at the chemical level. Avoidance becomes attraction. The mouse approaches the cat. The cat eats the mouse. Toxoplasma ends up inside the cat, the only host where it can reproduce sexually. Mission complete. A single-celled organism, no brain, not even a nervous system, just dictated the behavior of a creature that has both, all to reproduce. Now, people, I'll be honest, this one unsettles me, just a little. For over 30 years, a Czech scientist named Jaroslav Fleger has studied what Toxoplasma does to human hosts. The data is debated, and causation isn't proven. I want to be precise about that, but the patterns are hard to ignore. His team found that infected people are around 2.6 times more likely to be involved in traffic accidents, a result later replicated by researchers in Turkey. Infected men tend to score lower on self-control. Infected women tend to score higher on sociability and warmth. Same parasite, but opposite directions. This thing lives in the brains of roughly half the humans on Earth, and we still don't fully understand what it's doing in there. Maybe it's just living, maybe it's making plans, and we won't notice until it's already carried them out. But that's science fiction, right? When you say, my body, you're describing at most half of what's actually going on in there. The rest is them. You're not infected. You're an ecosystem. And given that you made it to the end of this video and are still fully functional, it seems to be working. What's the strangest tenant on this list? Drop it in the comments. Next time, we're heading outside with the things living around you. Some of them you've definitely met. See you soon. There's still more to tell.